In this video, we're going to use Maclaurin series and Taylor series to help us find the sum of the series from n equals 0 to infinity, minus 1 to the n, times 2/3 to the 5n all over n factorial. So what we're actually doing here is not necessarily finding a new Taylor series or Maclaurin series. We're trying to go back to what function is this series actually coming from. So we always resort towards the power series, Maclaurin series, or Taylor series that we know, and we try to look for clues that tell us which series is this series actually coming from. And what helps us a lot of times is basically identifying what factorial we see. So in this case, we have an n factorial in the denominator. So if we go over to the power series, we know we're looking for a power series with an n factorial in the denominator. So this clues us in that the exponential function might be useful here. So if we write this Maclaurin series relationship, we have x to the n all over n factorial. That Maclaurin series is equal to e to the x. So the name of the game now is sort of doing what we've done before for composition of functions with power series or stenciling with power series, but in reverse. We still do the same thing. Anywhere there's the variable x on the right and left sides, we replace with open parentheses and then get rid of those variables. So what we're going to try to do is take the series that we're given now and try to rewrite it and see what we need to put inside of those parentheses to figure out that this is an exponential or e to some number. So let's start with the series we're given. So we're given the series from n equals 0 to infinity, a minus 1 to the n, times 2 over 3 raised to the 5n, all over n factorial. And now a couple things to highlight. In the exponential functions, power series or Maclaurin series, we want a variable raised to the nth power, just like we see on the left-hand side here. So let's do that algebra. We have, well, this minus 1 is raised to the nth power, but we have this 2/3 is raised to the 5n power. So we can rewrite that as a 2 over 3 raised to the 5th power, that quantity raised to the nth power. So let me go ahead and just do that. So we have the series from n equals 0 to infinity. We have a minus 1 to the n. And now we have this 2 over 3, that quantity raised to the 5th power, but that whole thing raised to the nth power. And that's all over that denominator, n factorial. So why this is useful now is we have two quantities in that numerator, the minus 1 to the n, being minus 1 being raised to the nth, and we have this 2 over 3 raised to the 5th, that being raised to the nth power. So since we have the same power, we're going to be able to take what's inside and multiply that together. So we can rewrite this series now from n equals 0 to infinity. We can rewrite a minus times 2 over 3 raised to the 5th power, and that whole thing raised to the nth power. And that's all over n factorial. And this is actually very, very close to the exponential series that we're looking for, some quantity raised to the nth power in the numerator. We have the n factorials in the denominator. Now we just need to see what goes in those parentheses that we're raising to the n. And well, it looks like we have a minus 2 over 3 raised to the 5th power. So this is equal to then e raised to whatever's inside of those parentheses, which in this case looks like a minus times the quantity 2/3 raised to the 5th power. So this series is actually equal to whatever the number e to the minus 2 over 3 to the 5th is equal to. So the sum of that series is that.